we know that there's big constraints in the power system. We know that there's constraints in the Dublin area. And as the power system changes to bring on more renewables and transporting it largely a lot from the west of Ireland to that region is going to be a real mountain to climb. We need to supplement the characteristics we spoke about earlier on. But now we see that there's huge demand from data centers. And this has been very keen in the public eye over the last months and years as the message has gone out that the power system is operating at its absolute limit. So what types of traits are they bringing to the system in terms of the challenges that they're creating, but also what's the potential there for, we've spoken about down at the commercial and residential level in terms of what we feel can be done there, the challenges that need to be addressed. But now we go right to the opposite end of the system. And you're looking at the data centers that are coming online, consuming more power, but also providing services that are critically needed, electrifying them in Ireland, where we have an increasing renewable content in our power system is far better than operating them in other countries. We're dealing with a global problem here. But when we look at their characteristics, can you give us an idea of what challenges they present to the system, but also what are their inherent characteristics that we can try to extract the benefit of the operation of the grid?
Absolutely. I can certainly try. So at the kind of transmission system level, at the wholesale level, there are already kind of various programs in place to provide signals to large industrial and commercial customers to bring to bear the flexibility they have on the demand side, whether that's bringing on-site generation, adjusting their consumption profiles, or even providing very fast response services in response to frequency events on the grid. And companies like VIOTAS, we're a demand response aggregator. We're acting as a conduit to enable customers to respond to those signals on the grid to deploy the flexibility that's inherent within their sites and within their assets. So demand response aggregators, within Ireland are already making available, several hundred megawatts most of the time, that's there to support the grid. Data centers are, a good example of a large industrial customer that has exactly the kind of capabilities that the system needs. Most data centers have uninterruptible power supply systems, large batteries that enable them to ride through being disconnected from the grid or without any of their systems going down. Those systems are exactly like the large batteries that are being deployed around the island to provide the very fast response services needed to complement renewables. A lot of data centers also have backup generation systems that can run for several hours. Again, that can provide the sort of backup capacity that's needed on the grid when we have that confluence of low wind at the same time as we have winter evening peak. And making sure that we have enough capacity to meet demand. So data centers exactly have the type of inherent flexibility that if they're willing and able to bring it to bear, can support the system.
And the type of flexibility that they can offer is flexibility that helps to support the reason they're here, right? In terms of the renewable percentage in our system is good, but needs to increase. And data centers have a lot of the storage systems, the backup power systems that we're actually looking then to separately build in order to enable the power system to use more renewable energy. It already exists. And, when we look at building new, for example, open cycle gas turbines, I think one thing that we often forget about is the carbon associated with building it in the first place. We always think about the carbon associated with its use phase. So I think there's a negative perception towards the idea of using diesel generators, embedded diesel generators, in order to provide support to the system. But when you look at what's needed from a peak demand point of view, it's only quite a small number of hours per year where we hit that last 200 megawatts of peak, for example. And, we looked at it together and saw that if you build an open cycle gas turbine, it's about 200 megawatts, it's about 120 million euros plus 100,000 tons of carbon or thereabouts before you ever turn the key in it. Whereas you have these diesel resources, for example, sitting there. And if you use the diesel generators, I think John, you worked out it was a considerable period of time that we could use them for.
I think we worked out that, you could run those diesel generators for in the region of 50 hours a year for more than 40 years before a kind of state-of-the-art open cycle gas turbine burning natural gas had effectively made more sense from a carbon perspective, accounting for the build phase.